is 8th chapter, limits and continuity. This chapter belongs to mathematics 1b, part 26. Last parts completed, limits and continuity. Limits belongs to 4 exercises. That 4 exercises completed previous parts. That is infinite limits completed, standard limit problems completed, left-handed and right-handed limit also be completed. Some using standard limits, indeterminate form, determinant of form also be completed. This 4 exercise belongs to limits topic. Next topic is continuity. What is the meaning of continuity? First, discuss about the definition of the continuity. What is the definition of the continuity? Here, f from capital E to R. Here, the function f mapping from E to R. Here, E is called domain, R is called codomain or range. And A belongs to capital E. Here, A is a limit. That limit belongs to capital E, nothing but domain. Then f is said to be continuous at A. Then here function f is continuous at A if epsilon greater than 0 and delta greater than 0. Here epsilon and delta both are greater than 0, nothing but both are positive, such that modulus of f of x minus f of a less than epsilon. Modulus of f of x minus f of a less than epsilon, wherever x belongs to capital E. Here function x belongs to capital E, nothing but domain. If f is continuous on every point of E, here the function f is continuous on every point of E, nothing but in this domain E number of points is there. Here f is continuous every point of the domain. Here f is said to be continuous. F is said to be continuous on capital E. Here f function is continuous of every point of E. Then the function f is continuous on that E or E domain. Else nothing but if f is not continuous on every point of E, that that function is discontinuous. Else it is denoted by discontinuous. Discontinuous nothing but the function f is continuous on every point of E, that function is called continuous function. If the function discontinuous every point of E, nothing but not continuous on every point of E, that function is called discontinuous function. This is the definition of discontinuous function. What is the discontinuous and continuous? Both are completed. Continuous, this total definition is the continuous definition. This continuous, suppose the function not continuous in the interval E, that is called discontinuous otherwise. Okay, next this total is a definition. After that, what is the condition of any one function discontinuous? Here f is said to be continuous on closed interval a comma b. On closed interval a comma b, suppose f is continuous. Here 3 conditions can be possible. One is f is continuous on open interval. What is the meaning of closed and open interval? Here a comma b closed interval, nothing but the value lies between a comma b and included a comma b. That interval is called closed interval. The value lies between only a comma b, that is called open interval. Here the continuous on closed interval a comma b, but here first of all f is continuous on open interval a comma b, and left hand limit of a is equal to f of a, nothing but limit extends to a, f of x is equal to f of a, and limit extension of b minus nothing but left hand limit a plus nothing but here a plus nothing but right hand limits. This right hand limit value equal to f of a, this left hand limit value equal to f of a. This total you can write the condition of, write down one formula, the condition of f of x is continuous. F of x is continuous on limit A is limit x tends to A, f of x is equal to f of A. This is a formula of f of x is continuous yet function f of x is continuous at limit A is, what is the formula? Limit x tends to A, f of x is equal to f of A, or limit x tends to A plus f of x is equal to f of A, or limit x tends to A minus f of x equal to f of A. This is a very important formula by using continuous function, definition and condition. Next, f of x is discontinuous at x is equal to A. Last problem completed, last formula completed. F of x is continuous at x is equal to A. Three conditions is explained last formula. This explained f of x is discontinuous at x is equal to A. Here also be discontinuous having three conditions. First one is what? Here limit x tends to A plus f of x. This is which limit? Right hand limit. Limit x tends to A plus f of x and limit x tends to A minus f of x. This is a left hand limit. Here this one is a right hand limit. This one is a left hand limit exist. Nothing but the left hand limit and right hand limit both are exist to the given function, but are not equal, just exist, but LHL value is not equal to RHL. Left hand limit not equal to right hand limit, just exist. In this case f of x is discontinuous at x is equal to A. What is the second condition? Limit x tends to A plus f of x, nothing but this is what? Right hand limit, and limit x tends to A minus f of x, this is nothing but left hand limit. Both are exist and are equal. Here left hand limit equal to right hand limit, both are exist and equal, but not are equal to f of A. But left hand limit equal to right hand limit, but not equal to f of A. In this case f of x is discontinuous. Here left hand limit and right hand limit both are exist and equal, but not equal to f of A. In this case f of x also be discontinuous. What is the third condition? One or both of the two limits, that is limit x tends to A plus nothing but RHL, limit x tends to A minus nothing but LHL. RHL and LHL fails to exist, nothing but here right hand limit R does not exist or left hand limit R does not exist. In this case f of x also be discontinuous, nothing but what is the first case? LHL value is not equal to RHL value, left hand limit is not equal to right hand limit. In this case both are exist, but that values are left hand right hand limit both are unequal. In this case f of x is discontinuous. F of x is discontinuous. This is the first condition. What is the second condition? Here left hand limit is exist and right hand limit also be exist. Here left hand limit is exist, right hand limit is exist, and both are equal. Left hand limit value equal to right hand limit, but this value not equal to f of A. In this case f of x is discontinuous. Understood students? Here left hand limit exists, right hand limit exists, but both are unequal. In this case f of x is discontinuous. Next case is left hand limit exists, right hand limit also be exist, both are equal to one value, that is 1 or 2 or any one, both are equal but not equal to f of A. In this case also be f of x is discontinuous. Next step is what? Next condition is what? Here left hand limit is does not exist, right hand limit also be does not exist. Here left hand limit, right hand limit both are does not exist. In this case also be f of x is discontinuous. These three cases are very useful to solve the continuous and discontinuous problems. After that, here f of x is continuous, which condition? Here f of x is condition limit extends to a plus f of x equal to limit extends to a minus f of x. Here limit extends to a plus f of x nothing but RHL, right hand limit. Limit extends to a plus f of x nothing but left hand limit, nothing but LHL, and these two values are equal to f of a. These two values are equal to f of a. In this case only f of x is continuous. See students, this is very important. Left hand limit exists, right hand limit also be exist. Both are equal. These both values are equal to f of a. In this case only f of x is continuous at the limit x is equal to a. This is very useful and very important point by the definition of the continuous and condition of the continuous f of x at x is equal to a. These three conditions are f of x is discontinuous at x is equal to a. Today class discuss definition and conditions of the continuous and discontinuous. Okay students, next class discuss problems of the continuous or discontinuous.